All right, good afternoon, everybody. Today, what I'm going to be doing is going over question 2 for the Math Senior project. I'm going to go over sort of the theme of the project as well as what you have to do for exercise 1, 2, and 3. Okay, so I'm going to read the question for number 2. It asks us, how does the policy premium vary with SDIP? So I want to go a quick reminder of what the SDIP level is. The SDIP system, it's a step system that the insurance company uses to determine how safe or dangerous a driver is. Remember, 15 is like your starting point, and the lower your SDIP level goes, the safer you're deemed by the insurance company. And the higher you go, the more dangerous you are deemed by the insurance company. So what the question is asking is, how does the policy premium vary with SDIP? Your policy premium is simply just how much you pay for car insurance, okay? Or how much, I should say, how much you pay on a regular basis. It's often every month or every 6 months. It depends on the company. I know, for example, mine, I have Progressive, and I get a bill every month, and it's just deducted from my bank automatically every month. So and then my premium, I should say, is every 6 months. And so by looking at this big whole table of values and numbers and what the two columns that we want to be looking at here is the grand total, which is all the way on the right, and then the SDIP system, which is all the way on the left. Okay, we're going to be looking at does how does the policy premium, so these values all the way to the right, the grand total, how does that vary with your SDIP level? Okay, now it would just intuitively it would make sense, right, to have for companies to charge less for their safer drivers, right? That makes sense. If you're not getting in any accidents, you shouldn't have to pay as much. But what we're going to be looking at is, how much less do you have to pay if you're a safer driver, and how much more? Okay, does that increase by the same percent? Does it decrease by the same percent? Depending on how safe of a driver are you? So that's the information. That's what we're going to be doing for this question. Okay, so in order to graph these two, we're going to be using Desmos. Okay, so I'm going to log in here to Desmos right from the beginning. And then we're going to click on the top 3 bars on the left here and go back down to just the same that we were doing for exercise 1, statistics, linear regression. Okay, it automatically opens up this graph with your X and Y table and the information that it automatically gives you with the linear regression. Okay, this information we're going to be using later. So our x1 is our independent variable, the variable that's on the horizontal x-axis here, and that's going to be our SDIP level. Okay, so for an example, I'm just going to input the first 6 values. You guys are going to have to do all of them, but I'm only going to do a few of them just for the sake of time. So 9, 10. And then our dependent variable, the y value, is our grand total. The value is all the way on the right hand side. So $662.91, $790.48, $915, $1,025, 1,086, 1,025 and 29, 1,131 and 26. Okay. So now when we look at our graph, it actually looks kind of messed up. But we can fix it, okay? Using Desmos, you can click this graph settings little square at the top right, and we can adjust our axes. So looking at the table, whoops, I see that my x values only go from 9 to 14. So I want to make my x-axis go from 0 to 35 because I know that my SDIP levels range from 9 to 35. So I think this will actually make it a lot easier to read the graph. And my y values go all the way up to 1,131. So why don't I go my x values from, or I'm sorry, my y values from 0 to like 1,500. Yeah. Okay, so now we can actually see our graph. So that's a lot easier. Perfect. Okay. So this is what you're doing for exercise 1. Okay, you're going to graph the SDIP levels and grand total, plot it on Desmos, and take a screenshot, just like we did before. For exercise 2, it's going to ask you to fit a regression line to the data. Fitting a regression line is automatically done by Desmos. It gives you all the information that you need. Okay, this information down here underneath your table where it says y1 is equal to mx1 plus b, and then the statistics, the residual, and the parameters, that's what's required for these two questions. Okay. Anytime you have a regression line, it's always going to be in the form y is equal to mx plus b, where m represents your slope and b represents your y-intercept. Those two pieces of information, okay, are given to you right here, your parameters, your m and your b. Okay. And then to answer this question, how strong is the linear relationship? I have linked 2 Khan Academy videos in the assignment so that you can help, sort of tackle with these 2 questions to be able to interpret the regression line and to interpret this R value. This the R value, it represents your correlation coefficient. Okay, tells you how strong the linear relationship is, how weak it is, if it's moderate, positive, negative, and that's how you're gonna answer this question. Okay. Moving quickly along here, I want to get to exercise 3, so you know what to do for that. It reads, the insurance manual indicates that the collision insurance premiums are based on a step of 15, and then the premium is reduced by 7% for every step below 15 and increased by 7% for each step above 15. So this table here is showing the actual grand total versus our SDIP level, which we just graphed. And then it also has a column here for the grand total predicted. So you might be asking, what do I need to fill in for this grand total predicted? Now, if we look back at our linear regression model, we see this line of best fit. It's in orange here, okay? This grand total predicted, the values that you're going to be putting in here is basically the values that fall right along this line of best fit, okay? Now, if you notice all these dots here, they're pretty close to the line, but they're not exactly on the line, right? They're not, all of them are exactly. So we use predicted values to say if we didn't have a value for SDIP level 25 or something, based on the prediction, the predicted value, we can get a close estimate of what that might be like. Okay, so using the linear regression line that you get for exercise 2 and exercise 1, you'll be able to find out what all of your predicted values are. I'm going to go back to the .cam real quick to show you an example of how to find those predicted values. Okay, so on your table, we have we have a column for SDIP level. We have a column for actual grand total, and then this blank one for predicted. Okay, I'll go over the first one. The first SDIP level was 9, and the actual value, let me look back real quick. Sorry, guys. The actual is 662.91. Okay. Now we need to use this regression, this linear regression line here, this equation, and then plug in our input value of what our, which is ends up being our SDIP level. So the question is, how did I get this equation? F of t equals 78.04t plus 17 plus 63. Your values are not going to be the same as this because I only plugged in the first 6 values from the table. What I did was I took the parameters for the equation and then plug them into to this formula here. So I actually I did a different one in my previous example. So I'm going to use these numbers. I'm going to change it. So my m here in this case is 90.186, which is the slope. .186, and then my b values is negative 111.917. Okay, so this would be the equation that I would use, and I'm plugging in my dependent variable, my SDIP level, to find the predicted. So let's see what happens when we plug that in. $90.186 times 9 minus 111.917. $699.757. Okay, now your actual and predicted values should be pretty close to each other. So it looks like our this passes the test of making sure I did it right. And now let's look at our graph again. If you look here, this actual value is below my line of best fit, which makes sense with the equation too. The actual value is a little bit lower than the predicted value, so that looks like we did it correct. Okay. I'll do one more. I'll plug in f of 15. And we get 1,240.87 compared to the actual value. Oh, we didn't even do the actual value yet. That's fine. Yeah, but I think you guys understand at this point. We're plugging in the SDIP level into your linear regression, and then comparing the predicted to the actual numbers. This comparison between prediction and actual numbers is what you're doing for exercise 3. Okay? So you're going to fill in the rest of this table for the grand total predicted, and then answering, does the data for the average premium and SDIP support the percent increase described here? If not, what could be some reason for the difference? Okay, so I'm going to stop the video here. Hopefully this helps you guys with exercise 1, 2, and 3. As always, reach out if you have any questions or concerns in regarding the senior math project, and good luck.